So pressure is a measure of force that a gas exerts on its container. Atmospheric pressure would be the pressure that's pushing down on all objects. So our units of pressure, we have 1 atm or atmosphere is equal to 760 millimeters of mercury, which is equal to 760 torr, which is equal to 101.3 kilopascals. All of those are standard pressure. Standard temperature would be 0 degrees Celsius or 273 Kelvin. You'll need to be able to convert between pressures. So if you've forgotten how to do so, remember that you start with what you're given. Units, what you're given on bottom, and what you're converting to on top. 760 always goes with millimeters of mercury, and 101.3 goes with kPa. Multiplying and dividing, we get 53.8 kPa. So what causes pressure? The number of collisions and the force of those collisions. When we're talking collisions, we're talking about collisions with the walls of the container. If you have more collisions with the gas particles, you'll probably also have more collisions with the walls of the container. If you increase one or both of these, pressure is going to increase. So look at this picture and figure out if A or B would have a greater pressure and justify your answer. Remember that greater pressure means that you have more collisions. Pause the video and restart when you have your answer. When you see pictures like these, the arrows are going to represent the velocity. So the longer the arrows, the faster it's moving. So again, greater pressure means more collisions. So in A, we have 5 molecules, while in B, we only have 3. So A would have more collisions. More molecules will result in more collisions, thus a higher pressure. Go ahead and pause the video and try this one on your own. Restart when you have your answer. So in this case, we have 3 molecules each, but in B, the arrows are longer than A, which means B must be moving faster than A. So B has the greater pressure because the molecules in B have a greater velocity, meaning they will collide more often and with greater force. So anytime it's moving faster or has a greater kinetic energy, it should be colliding with a greater force and more often. So there should be 2 reasons why it has a greater pressure, not just one. Go ahead and pause your video and try this last one on your own. Restart when you have your answer. So in this case, we have volume being changed. A is going to have the greater pressure because it has a smaller volume. Smaller volume will result in more collisions because there's less space for them to move. So let's look at our gas laws that relate what those pictures are saying quantitatively. So Boyle's law is what we just saw in that last picture. It says that pressure and volume are inversely related. P1V1 equals P2V2. As long as pressure and volume are in the same unit, it doesn't matter their units. Charles's law is a direct relationship between volume and temperature. Temperature in this case must be in kelvins, but volume it doesn't matter. And notice our graph for Charles's law showing the direct relationship. Gay-Lussac's law is pressure and temperature. Just as Charles's law, they're directly related. Pressure doesn't matter as long as they're the same unit, but temperature in Kelvin. And you can see it's the same graph as Charles's, except pressure and temperature. The combined gas law is P1V1 over T1 equals P2V2 over T2. And it's going to combine those last three gas laws. Avogadro's law is volume and moles. It says the greater the moles you have, the greater the volume you have. So it's a direct relationship. At the bottom, that's important to know. If the temperature, volume, and pressure are the same for two gases, they're going to contain the same number of moles. And remember that 1 mole is equal to 6.02 times 10 to the 23rd molecules, and so it would have the same number of molecules as well. But it would not have the same number of grams because molar mass is not the same for two gases usually. Go ahead and pause the video and try this one on your own. So we have a volume of 5 liters and a pressure of 16 atm. So we're dealing with volume and pressure. First thing you need to do is write out your equation. So every problem, write your equation out first, and then you can plug in your values. So we have 5 liters, 16 atm is equal to 4 liters and an unknown pressure. Our volume went down, so our pressure should go up. And it does. It goes to 20 atm. Okay, go ahead and pause the video and try this one on your own. So in this case, we have a pressure of 300 kPa at 200 Kelvin, and we raise the temperature to 500 Kelvin, and we're looking for the new pressure. So we have pressure and temperature, or Gay-Lussac's law. So I wrote my equation. I can plug it in. Make sure you read carefully because sometimes they'll say we raised the temperature 500 Kelvin. We didn't do that in this case, but had we done that, then it would have been 700 Kelvin as the final temperature. I can solve that algebraically or cross multiply, and notice that my pressure went up. I'm going to pause the video and try this one on your own. This one is a little bit trickier because it's the same temperature and pressure, which means our volume is changing, and so our moles are changing because we're changing substances, and our mole to mole ratio is different. So we need to balance our equation, and then we're going to have to convert those 0.5 moles of oxygen gas to moles of ozone. So we know that we're going to end with 0.33 moles because we're converting all the oxygen to ozone. And so now we can just plug in our values. So we know our beginning volume, beginning moles, ending moles, cross multiplying, and I'm going to get 8.1 liters. Go ahead and pause the video and try this one on your own, restarting when you have your answer. So here we are changing everything, which means we're going to have to use the combined gas law. Okay, so I have 56 ATM. My volume is 6.33. My temperature is 90 degrees Celsius, but I can't plug that in because that's not in Kelvin. So adding 273, I get my temperature of 363. My next pressure is 1500 millimeters of mercury, but that's not going to cancel out with ATM, so I'm going to have to convert that. Doing so, and I get 1.97 ATM. I'm looking for my volume, and my temperature is in Celsius, so again I have to convert that to Kelvin, giving me 523. Cross multiply, and I get 259.3 liters, which is not on there, and so I'm going to choose none of the above. Finally, remember that at STP, 1 mole is equal to 22.4 liters. 1 mole of a gas. This is only for gases, not liquids or solids. So, in this case, we have 1.75 liters at STP. Once we realize it's at STP, we can use 22.4 liters is 1 mole. Dividing that, and you get how many moles, which is 0.0781 moles. Go ahead and pause the video and try this one on your own. So again, I'm at STP, so I can convert my 152 grams to moles. The molar mass of calcium carbonate you should have got was 100.09 grams. Once I have moles, I can do my mole to mole ratio since I need to get it to carbon dioxide. And finally, 1 mole is equal to 22.4 liters. Solving that out, I get 34 liters. Remember, this can only be used if it's a gas. Do not use this if it is a liquid or a solid. You have to use density to figure out the volume for liquids and solids. And that concludes part 2.